So what we're going to do today is learn a few more of the features of the calculator, the regression features that the calculator can handle. We've done several. This is when we do stat, calc, and we put lists in and stuff. We've done a couple, so let's just review the ones that we have done. We've done parabolas. These are the ones that have that U shape, and you can recognize them by the U shape. We've also talked about, but we haven't done the regressions on logistic, which is in the worksheet. It comes right underneath the quadratic. A logistic you can tell because it has a bottom section that's flat and an upper section that's flat, connected by a steep section in the middle. The two flat pieces, okay, the ones that sort of level off, that helps you know that it is a logistic shape. The two we're going to talk about today have only one piece of them that is more flat. We are going to talk about logarithmic, which is ln, and its flat piece is near the top. It starts out steep, but then it just sort of peters out and levels off. Sometimes we call that a lazy logarithm. Like it starts out looking really good, and then it just sort of loses steam and gets flat towards the end. You can tell that is a logarithm. And the other one is an exponential. Its flat piece is at the bottom. That kind of a graph starts with a real flat, kind of boring section, and then it gets really excited really quickly, and then shoom, it shoots out, and it has an increase that goes up. We maybe call that an excited graph. So you've got a lazy graph that sort of levels off. Those are logarithms. Just think of all those L words. Lazy level logs. Okay, a lazy level log always just kind of heads off sideways. And then an exponential is an excited graph. Okay, it's an eager and excited exponential, those E words, and it just heads straight up to infinity. So you need to be able to recognize those two shapes, these two here, for our graphs today, so that you know which one to run on the calculator. Okay, so now, would you take that table that's on the worksheet and would you transfer that into your calculator under your stat edit? So let's just remember how to do that. So go to stat, go to edit, and then put those numbers in. So 2, 3, 4, 5, 6, 7, 8, and 9. And then in your list 2, L2 column, those other data points. Once you have those data points in, you'll want to decide what your window should be. And so looking at the data for our x values, I think a good idea would be to have our minimum be 0 and our maximum to be 10 because of the data points go from 1 to 9 with a scale of 1. And the same thing for our y values, 0 and 10, again because of the minimum and the maximum with a scale of 1. So if you could set your window to 0 and 1, then turn your stat plot on, and I'm going to walk around and I'm going to check that each of you have the graph. And so set your window to 0 to 10 for both the directions, and then make sure you go to second y equals and you turn your first plot on so that we're all looking at the same picture. And I'm going to walk around, so if you could just turn your graph facing me, that makes it quicker for me. So this graph you should recognize as being an exponential. Okay, you can tell it's exponential because this bottom edge down here looks like it's starting to level off and be flat. And when it's flat on that side and then heading steeper in the other direction, it's part of an exponential graph. Okay, whoops. All right, so we are going to actually skip question 4 and just question 4. Because question 4 is asking if it's maybe it's a parabola, and so I was going to have you run a parabola on that and write down the correlation coefficient. But we're going to skip that part because I know that the exponential is going to be better. All right, so we're just going to go ahead to the next part. So go ahead and hit stat, go over to calc, and you need to find the exponential one. It's kind of near the bottom. So we have done ln reg, we've done quad reg, cube reg, we've done all these, but exponential reg is option O or option 0. And so you want to run the exponential regression. So go ahead and select that. And remember, when we do that, you put in L1, you put in L2, and then the regression equation, I do need you to put in a y1 value right there. So make sure you use your vars key. If you do not do that step, you won't get a completed graph. It'll just keep giving you dots instead of having the curve to go through the dots. So you want to make sure that you do indicate that. All right, and then calculate. And it will come up with an exponential regression for us. So we're going to copy this onto our worksheet. When you do this, the 0.508 is your A value. And what I would like you to do, instead of star, which star means what in calculator language? It means times. I would rather you put a parentheses. Okay? So A parentheses B, please. Okay, it's going to be better for us in the long run. So go ahead and copy those numbers down. This is under number 5. And you can round to the nearest third decimal, it would be fine. So 0.508 parentheses, and then in the parentheses goes the B value, 1.36, actually 1.370 when we're rounding, and then outside of the parentheses would go your X for your power. And the correlation coefficient is the R value of 0.9985. So the worksheet should kind of look like this. Okay, where you're recording that, make sure you put your 1.3, I rounded 698, rounded to 70, and then to the X power. This is an exponential. All right, now hit graph. And when you hit graph, not only should you see your dots, but you should see a nice curve going right through your dots as well. And that comes because you put that y1 into that equation. And so you can answer number 6. Does this closely match the value? And actually number 6 is asking you which one's better, the parabola or the exponential. If you want to, for number 4, if you want to go back and put, it was 0.993 was the answer. And so then the quadratic is not as good as the exponential. The exponential has a better correlation coefficient. And so we would say the exponential is better for number 6. Okay, has a higher rate of match, a higher correlation coefficient. All right, number 7, use the model and predict the value when X is 20. So what's the best way to predict 20 using our calculators? Yeah, we're going to use the vars feature. So go to vars, pick y1 because that's the model that's best, and substitute X to be 20. And then it will do the math for you and tell you that the answer is 274.934. All right, any questions on example 1? Okay, let's move on to example 2. So go to the second page of your worksheet. Go back to your stat, and you want to clear out the lists that we had before. And you want to put in the new ones, please. So it'll be 1.5, 7.4, 10.2, etc. So this process you know already. You've done this before. We're just doing it with new shapes, new different regressions. We've done linear, we've done quadratic, we've done cubic. We're now doing exponential, and now we're going to do log. On your worksheet, the window you should record should be a little bit modified. The X is fine to leave it as 0 to 10, but the Y should change. What should your new Y max be, according to the worksheet, at least to the data? I think 20 would be a good option, so make sure you pick 20, the scale of 2. And so your window should go up to 20, and then also make sure you clear the old y equals from before. And then turn your calculator around so I can see that you've got that graph. Okay, these data points have a different shape. They get flat in a different way. Okay. This one starts out steep, but then starts to level off. Okay, things that level, we say are lazy. This is a logarithm, and so we need to run the logarithm analysis, the regression on this. Okay, make sure you pick the right one. Go to Stat, Calc now. Now be careful, because some people will pick the wrong options. You get down and there's several things that all start with L. Number 8 starts with L. It's another len reg. We do not want to pick line. This is not a line. Letter B starts with L. That's logistic. That's not this either, because a logistic has 2 flat sections, and this one only has 1 section that's starting to get flat. So the correct option is number 9. Number 9 is LN, which stands for natural log. The problem is that some people see LOG for logistic, and they think that means logarithm. LOG for logistic is different than logarithm. You need to pick number 9. So pick number 9 as your logarithm, and then go ahead and also put in y1 again and calculate that. And then go ahead and record that onto your worksheet under number 6. So you'll have y equals, you'll have 1.538 as your A value, plus B is 8.373, and then ln x. And the correlation coefficient for this is 0.997, so also very strong. Actually, that should, I misspoke. Yeah, no, we're right. We're correct. We're going to skip number 7. Number 7 was the logistic. Logistic is not the right option here, but in the worksheet design, I was going to have you, if we had time, do both of them so you could see which one was right and which one was wrong. But the right one is the logarithm one. Okay, now that you've run it, graph it, and make sure you have the line that goes right through. Okay, now I want to plug 15 in 2 ways. I would like to show you how to plug 15 in for x, and I'd also like to show you how to plug 15 in for y, because your calculator can handle both things. You already know how to plug 15 in for x. Go to vars, pull up your y vars and put 15 there, and then that's plugging in 15 for x, and the output then is y, and you can put that in number 9 on your worksheet as the answer. So 24.213. If you want to plug 15 in for y, you can do it on paper and you can cross multiply, but your calculator can do it also. If you want to plug 15 in for y, you do it in your y equals, and you make 15 the second entry, and that will plug 15 in for y. And then you go ahead and graph that, and now you're going to see a line come across at the number 15. And you'll use the second trace feature to figure out the answer for that. So let's do second trace. Option number 5 to intersect. Make sure you hit it 3 times, and then it tells you that the answer is 4.991, which is basically 5 for that. When I plug 15 in for x, what kind of unit is x usually? Time. X is usually time. When I plug 15 in for y, what is y usually? Like a population, okay? And then we go work backwards and figure out our time that way.